Yes, you can come.
Yeah, looks there.
So I'm at this Liberty Living Labs in Paris. It's office here that my colleague Fuzi Bengaluru, who I work on the Paris City project with, has an office here, which is just down the street from the hotel where I'm staying.
Okay.
Instead of being in India.
Why are you in Paris?
It was an attempting. It was a way of hopefully getting to the meeting in time.
Oh, I see. I see. Okay.
If I got my visa and I stayed in Washington, I would have no chance.
Good morning, Phil. Phil, good morning.
Good morning, everyone.
Yeah. We'll start now.
A very good morning.
A very good morning to everybody. I am Vrinda Anand on behalf of the NIAS organizers. Welcome everybody to the Strategic Roundtable on the formation of Science and Policy Consortium for Greenhouse Gases and Ozone-Depleting Substances in India. We're very pleased to have everybody here for this event and also everybody who is joining us online. So to begin with, I invite Professor Gufran Beg, who is the convener of this event, NIAS Bank. So Dr. Beg.
Good morning to all of you, and I just very brief, I would like to welcome you all on this very important event. And Phil Decola, as you said, that he is in Paris, very enthusiastically attending from there. What I would like to do that our director will give the inaugural address. But before that, I just wish to show you one or two, three slides, just mentioning that what really is something which has made us to have this very important meeting, and what are the pressing questions which I think in a deliberation we will ask. So, just can you? Where is the gentleman whom I have given the slide?
Yes.
No, not this is. There is a presentation which he has saved with my name in a folder. Yes. Okay, so this is a formal welcome to this. As you can see that it has been very kind that it has been endorsed by the World Meteorological Organization, where there is a group with Integrated Global Greenhouse Gas Information System, the co-chair Phil. Then I am very happy that in Indian government that SPOGO, Department of Science and Technology, is something which has recognized as a knowledge partner. And obviously, National Institute of Advanced Study has taken up the responsibility to steer that. Very quickly, I will go to the one or two slides next. Now I can. So it is basically the motivation is this, that we are all concentrating on greenhouse gases, CO2 and all. But then there is a fact that the ozone depleting substances like HFCs, and other short-lived climate forcing pattern is responsible for about 45% of the global warming. And as the acceleration research in advocacy of greenhouse gases, ozone-depleting substances, these are critical. And if we take a leap in this particular thing, we would be the leaders in India. Only 2-3 countries in the world have started such kind of a effort. Next. And just to give you a glimpse that our recent advancement is this, that even our own, with the NIAS, with other people, we could develop a methane emission inventory with 10 by 10 kilometer, all with this, which is in the publication stage, and then these are the bifurcation of that with a lot of activity data, but many more presenters will do that, but this I thought that it is a very important result, is first of its kind, so I thought that I will show that. Next. So, very important is which I would like to say that we are all industrial colleagues will also be getting interested that when the Montreal Protocol everything we shifted to HFCs, but that time it was not that much seriously realized potential, and then this is to show the Kigali declaration is something where it says that HFC need to be phased out. So basically, when CFC that bad situation for ozone as well as for the global warming, for the climate change. But then HFCs came, and we need to have alternate technology to get some kind of a substances which can replace HFCs, which has a very low global warming potential. And this is a challenge which we would like to discuss in that particular thing. Next. So finally, research and solution, just in 3 slides, and then I just close this. So it is just giving you seeds of discussion that major greenhouse gases, short-lived climate pollutants, rapidly increasing as India's cooling demand, because India is going to be a booming economy. It is increasing, one of the fastest growing economy. The cooling demand has to increase to time to come, where in the Western other countries is almost saturation. We have another sources are like increasing livestock, cattle, paddy, high, all those. So develop emission inventory, develop monitoring network, develop alternate climate friendly technologies. These are the something which is making us with this. With this, I think I just close that and welcome you, all of you, to kindly be interactive, be participating. This is more of a interactive round table where everybody's thoughts are important. The talks are something which will just pay the background of that. Thank you very much, Brenda.
Thank you, Professor Gufran, for the welcome address. Now I invite Dr. Shailesh Naik, Director NIAS, for giving the inaugural address. He has been the backbone of this roundtable, so I invite him to give the inaugural address. Professor Shailesh.
Yeah. Thank you very much. I join Gufran in welcoming you all, and I would like to place on record my sincere gratitude to Phil, Nicola, Gufran, Persis, and Yogesh, who has been discussing for quite many months or many weeks together about putting this program together. The basic idea behind this program is to bring together the global experts on this field, the representative from the government, representative from the industry, and also the social scientists and various other non-governmental organizations who are also looking at the policy. And I must say that I'm really pleased the kind of response which we have got, because most of the conference, when we get either one of them, you can't get all the 4 together. And that is, I think, is the most important thing for this workshop. This issue we would like to address from three different approaches. The first is we need to generate a knowledge on the various aspects of these greenhouse gases or ozone-depleting substances. And we'd like to understand that what is actually happening, in the sense that when the Industrial Revolution started, nobody knew what carbon dioxide can do. Of course, the nature has its own resilience, and up to certain level of carbon dioxide, there was not much of issue. When it started increasing from 280, 300, 350. But when it went beyond the threshold, probably around 350 or so, but there could be debate on that, what is actually a threshold. And now for 20 plus, we have been seeing the kind of impacts, and we have been trying to understand. Similar thing happened when we replaced CFC with HFC. Similarly, maybe for methane and many other things. And many times I have been seeing that, somebody will say that methane is more dangerous than carbon dioxide, etc., etc. But I think we need to look at all these gases in entire way, in the sense that what is their life cycle? Maybe for carbon dioxide, maybe 100 years, for methane, maybe 9-10 years. The warming potential could be different. What is the total concentration in the atmosphere? Do we know that up to what level we can sustain, or what should be the threshold value? So putting all this together, we need to find out what is likely an impact. And whatever the alternate strategy or alternate gases which we may be proposing, we should also have a full knowledge about it, because after 10 years it should not happen, oh, this is again becoming an issue. Because one thing is definite, is that whatever you may do, there is bound to be some impact on the environment. Now, we should use our knowledge that how do we minimize this impact. And that is why we need to generate a knowledge on all these aspects. So this is the first level I think we need, because there are many gaps in this knowledge. And we need to fill this gap so that we can have information. And that this information may be existing in different countries at a different level. And the first task should be to synthesize our knowledge of these gases and identify the gaps. The second is very critical, is that how do we use this knowledge for the policy making for the government as well as for the industry, and what kind of infrastructure we may need to put this into a practice. And I'm very happy that we have the representation from both these places, and I'm sure that they will come up with their own views or perspective about these aspects. When we synthesize knowledge, we need to interact with the industry, government, to find out what is that kind of information they are looking for. So we may have to translate this knowledge into some kind of an actionable policy or actionable action for the industry that they can easily take it up. We can't expect everyone to be an expert the way these scientists normally provide the information or research papers or may not be easily amenable. So I think there is a need to synthesize this knowledge and provide this for the government as well as to the industry. And there may be a gap, so how do we plan to fill in the gap? So it has to be a continuous process where we generate newer knowledge and improve upon what actions are needed. And the third aspect is also equally important. This is one is the knowledge system, the second which I talked is about social system, and third is about the human system. That how this information is useful to the common people or the society. In the sense that whether there are health hazards for them or whether they are aware of what we are using in our day-to-day life, how it is affecting the environment. So we also need to generate the information, or we should be able to communicate about the likely impacts of this to the common people and these communities. I think this is what we need to do, and I would say this is just a beginning today. We would hope that this kind of activity is sustained and we can take stock of, say, every year or so what's happening and then plan what we need to do. And in NIAS, we would be very happy to provide that support because we have been working on many such issues that how we can integrate the science and technology with the social science. We have been working on many issues right from the energy transition to air pollution to climate change to inequality in the system to the conflicts, peace research and many other things. So I think I wish very best for today, and I hope that the discussions and the deliberations which we have would be very fruitful to make the certain recommendation. And I very strongly recommend that we need to create a framework by which we can generate this knowledge, synthesize it, and translate for the government and the industry. With these few words, I wish very productive workshop. Thank you very much.
Thank you, Professor Shailesh Naik, for the inaugural address. I also request you to chair the session until coffee break. So over to you, Professor Shailesh.
Thank you very much. Next, I would like to call upon Professor Ravi Shankar from Colorado State University. He would speak on the case for India building its own capability to determine MP gas emissions. Professor?
Yeah. Thank you, Dr. Naik. Good morning to all. Just a word on my background. Actually, my entire scientific career started with dealing with the ozone layer depletion because I went to a talk by Shirley Rowland about it. So what I'd like to do though is I'm one of those people who actually have, I was born and raised in India, as you can tell, if you look at me. I've been away, but there's always this urge to do kind of bridge between I'm part of the Indian diaspora, let me put it bluntly. So take it from that perspective that I have those intentions in mind. So what I would like to tell you, very few brief points. I just want to first point out that India has been playing a leading role in the Montreal Protocol process from the very beginning to the current amendments. And then I'm going to tell you a little bit about the transition of the Montreal Protocol from an ozone treaty to what I would call a climate treaty by including HFCs, that is the hydrofluorocarbons. And I'd like to just then paint a short picture of what happens if we don't know our own emissions. It actually has, there's a case study that I'll present. If Steve Monska, I think he's online, if he were giving a talk, he'll tell you a lot more about it. Unfortunately, I didn't have time to include the slides in the presentation. I'll just make a couple of comments. The heart of the issue is for emissions of ozone-depleting substances or the Montreal Protocol gases and many others, you have to do in situ monitoring, and you can't always derive it from satellites. So that's a very important thing to kind of get your hands around. And then I'm just going to end by looking ahead as to what can such an information system provide for India and other neighboring countries and countries undergoing economic transition. Can I have the first slide, please? You know, long time ago, we used to predict that the ozone layer depletion will be a few percent. What is shown there on the left-hand side is what I call the Wiggle diagram. This guy kept predicting what would happen using models. If CFCs continue to be emitted until in 2050, we would have seen a significant amount of ozone layer depletion. But as you know, the ozone hole and then the other ideas, other discoveries clearly show there's a lot more ozone depletion than was predicted. And then they caught up with the knowledge, and now we know what it looks like, what the current state of the ozone layer, and what's happening to the Montreal Protocol gases. Could I have a click on the next slide, please, for a second? I didn't see. Okay, great. I just want to tell you this point, or make this point. It's not only necessary to know what it is today compared to what it was yesterday, but it's more important to look at what is today compared to what would have been if something wasn't done. The thing that shows there is one of the many calculations that if CFCs had not been controlled, countries like India in the tropics would have had a massive ozone layer depletion, and it would have had an enormous impact on agriculture and health and all sorts of stuff. Second, CFCs would have been competing with CO2 emissions today. CFCs would have been as important greenhouse gas as CO2. So the fact the Montreal Protocol controls CFCs for the ozone layer protection had a very important, I would say intended, side effect of helping climate. Click, please. So, India contributed to the adoption of the Montreal Protocol. It ratified it, and it helped prevent disastrous global ozone layer depletion. India should take full credit for it. It would have suspected the tropics would have been amazingly bad, and then it avoided this enormous issue of competing with CO2 as an ozone layer depletion gas, climate gas, and the tropical ozone layer. The thing though, I want to point out that the Vienna Convention, which bears the Montreal Protocol, actually recognized the climate impacts of the CFCs. In fact, Professor Ramanathan in 1975 was the one who showed that CFCs would be a very bad climate gas. Next slide, please. This is a slide from a paper that just appeared a couple of months ago by an author, Garima. Unfortunately, I don't know exactly where this, he or she, I don't even know the name, is in Delhi. You can't see the slides, but the figure too well, but I'll tell you, if you were to look at very closely from 1998 to 2011, it shows how India phased out CFCs. And it phased out CFCs ahead of schedule when it was supposed to. It is doing the same thing for HCFCs. It had really avoided building a large CFC-based industry. It moved ahead, and it enabled better overall efficiency in the process. The increased efficiency with the substitution is something I'm sure there are people from the air conditioning sector here who can vouch for. It is a big factor. Next slide, please. So the Montreal Protocol's overall strategy was to first phase out CFCs, then HCFCs, then we go to HFCs, and then essentially to get to kind of having alternate technologies. It was not like it was a stated strategy, but it worked because industry and science and the policymakers worked together to make it happen. And on the right-hand side is a picture from the HFC report that Mario Molina, Gus Wilder, Melanie, and I put together, which kind of was the foundation for the Kigali Amendment, which just shows you what would have happened if nothing had been done with HFCs, and what will happen with the shorter-lived substitutes for things like HFC 134A. So India's technology actually has been looking ahead. In fact, India is one of the first ones to have hydrocarbon-based air conditioners. Resurrection of that whole thing. Next click, please. So this greatly reduced climate forcing the CFCs, and I told you all this. And the key point I would like to make here is it allowed for the emergence of not-in-kind technologies and other chemicals. Very important. But knowing how much of this is coming and going and who is emitting how much is an important issue. Next slide, please. Okay, this is a slide from Tina Bimpali. She is the director of the Ozone Secretariat. And essentially, it's a statement saying that the Montreal Protocol transitioned with the Kigali Amendment from a purely ozone layer depletion protocol to a protocol that helps mitigate climate change, specifically in terms of HFCs. Next slide, please. So this again shows how the industry worked with the science and policymakers and how the markets penetrated using alternate technologies. If you look very carefully on the right-hand side, that says the market share of the low GWP alternatives is happening much faster than people expected. Next slide, please. So this is, I don't want to sound like I'm philosophizing, but this is what I would call the accountability phase of any protocol. You have a protocol, what you do in this is you have a goal and you take some action, and then you have to know that you've actually solved the problem. You've met the ultimate goal. And as you go along, you have to constantly keep tweaking what you're doing. So it, of course, starts with the discovery and diagnosis. Then you measure, understand, and assess, which leads to policy and management. Then you continue to measure and assess to ensure that you're getting the desired results. And there are lots of feedbacks in this process. So as you can see, in this paradigm for how to deal with any kind of an environmental issue, measurement is essential. It's an essential component of a successful management system. Next slide, please. So here's an example of steel.
Here, you would have given them much better.
Thank you. Steve would have done a much better job explaining this. On the left-hand side is a picture from his paper in Nature about 4 years ago, but showed that global measurements showed that the CFCs are actually going up emissions rather than going down. And then further research by various researchers showed that it's actually coming from China, and a big part of it. We don't know exactly if all of it is, but it's a big part of it. On the right-hand side is a picture that Susan Solomon Joe Alcomond had in Nature last year, or the year before, which essentially showed what is the potential discrepancy and what is the options for mitigation. So the point is, a country or an industry or any sector involved in emissions, it would be better for them to know what they're emitting. You cannot rely completely on accounting to do that. Accounting gets you part of the way, but it's really important to know what the atmosphere is telling us. Next slide, please. And I would also point out, here's a very costly experiment thing that they had to deal with. So I'm not going to spend too much time on what's on the left-hand side. I just briefly mentioned that to you, and what's the opportunities here. But I want to spend a minute on the right-hand side. That's a paper Ray Wise, Paul Newman, and I wrote it and published in Nature last year, which essentially shows you a map of the world as to where emissions are being monitored and what is the footprint for the detection of those emissions. What you see is two glaring things. There's a vast amount of the earth where we do not have sufficient monitoring, India being a prime example. And the second is those are precisely the areas where you expect large increases in the usage of these chemicals. Here's the opportunity. Usage does not mean emissions. Usage is what you do. You can do it in such a way you don't have to emit into the atmosphere, but knowing what you're emitting is the key. So I would argue that this ability to monitor is a very cost-effective way for providing policy information. Next slide, please. So I just want to end with a couple of quick points. If you were to build your own system, I would say a system, not just monitoring. It has to go with various other components with it. It will allow Indian policymakers and managers to know emissions before being pointed out by somebody else. You don't want somebody else pointing their finger at you. You should know yourself. Atmospheric monitoring plus inverse modeling allows for quantifications, and it allows for quantification by sectors and regions. That's very important, because if you want to take action, you just don't want to know something is coming from India. You want to know what sector in India is leading to those emissions. That's the simplest way to actually get a handle on management. And it is essentially source apportionment is what happens. If you start with F gases, that's all man-made. So this whole question of man-made versus natural becomes easier. And I would argue that it provide a very good training ground for doing other greenhouse gases at the same time. So building an information system of monitoring, inverse modeling, reporting would help India. And I believe if India as an Article 5 country were to develop such a system, it could be exported or should be exported. Its neighbors and other countries, I would argue that Africa is ripe for such measurements. South America and Africa are other two major increases in population and usage, and India could be actually in the forefront of providing such health information. The information system can be expanded to address other environmental issues such as air quality, mercury, and various other things that you might be thinking about. So that's my little plea to suggest that India will benefit from building its own information system. With that, next slide, please. I thank you for listening to me. I'll be happy to answer any questions.
Thank you, Professor Shankar, for very briefly, but very emphatically you said why we should have our own information system. So thank you very much. With this, I would invite Dr. Phil DiCola, who is co-chair of WMO group of 3IS at the University of Maryland. He will speak on "You Can't Manage What You Don't Measure," the Integrated Global Greenhouse Gas Information System. So Phil, over to you.
Thank you very much. A number of my colleagues who are online with me, Steve Monska, Anita Gonison from Bristol University, Steve Monska is from NOAA, the National Oceanic Administration in the US, Anita Gonison from Bristol University, and Alistair Manning from the UK's Met Office. And I want to thank these folks who have worked together to conceive of this gathering today, this roundtable discussion, and the value of it that we believe will come going ahead from today and tomorrow's discussions. And I want to emphasize what Mufan Beg and Professor Nayak have already said, that this is intended to be a discussion. We're starting with some seed material with presentations, but we want to, as soon as we can, move to the discussion period and open the floor to more ideas and to digesting what we're hearing and answering questions. So the next thing I wanted to say after those thanks is to apologize for not being with you in person. Unfortunately, I did not apply early enough for my visa. It's my own fault for not paying attention to the timing. Of course, please forgive me, I'm very busy with many things, including helping to organize this gathering today. But so as a result, I'm unable to get all the way to India. I've come halfway from my home in Washington, D.C. to Europe, where I'm sitting, and hope that I would still get there, and I still hope so, maybe later this week. However, I'm stuck here in France right now, instead of being with you where I really want to be. So now let me try to share my screen. I was able to do it earlier, successfully. And let's see, can you see my screen? Hello? Not yet.
Share the presentation. We are able to see your screen.
I'm sorry.
You, Phil, move to the right.
Just a moment.
A little bit more. Little bit more. 1 inch in the right hand side.
Do you see the presentation now?
Yeah.
Yes.
You see it?
Yes.
Okay, great. Is it full screen?
No, but that's okay.
Yes, it is.
Is it in presentation mode?
It is.
Okay,
Waiting
great.
to go.
So what I'd like to do briefly now is two things. First, I want to thank Ravi for starting to get us in the direction of understanding the power and the value of combining what we call the bottom up, which is information, accounting information that takes advantage of counting up the activities that produce human emissions, such as power plants, buildings, mobility, transportation, waste management, agriculture, many different things produce human emissions. And so we take a bottom-up approach by counting up the activity and multiplying by emission factors. And as Ravi said, this gets us somewhere towards where we need to be. But then what we've learned in the research environment and increasingly we're starting to apply this capability, if we combine that information from the bottom up with the top down, where we measure the atmospheric concentrations and how they vary in space and time, and then analyze them with inverse model analysis and other techniques, when you combine all of that information, what the atmosphere tells us and what the accounting tells us, we get the very best knowledge of our emissions in terms of accuracy and precision over time, consistency over time. That also gives us granular information that does what Professor NIAS suggested we need to do, is find actionable information. He used the word actionable. And by having information that's granular in space and time, we can actually target opportunities of reducing emissions and then track the efficacy of those actions over time. So I'm going to do two things really quickly. I'm going to first introduce an initiative that was mentioned already, the World Meteorological Organization Integrated Global Greenhouse Gas Information System. And one of the things that it is, it's a team of scientists from around the world, which includes Yogesh Tiwari from the Indian Institute of Tropical Meteorology. It includes Alistair Manning, who I introduced, and Anita Ganesan, and many other scientists from countries all around the world. And I'm going to tell you a little bit about that initiative, and then I'm going to give some examples of what Ravi talked a little bit about and what I just hinted at, which is, what does it look like when you combine the information from the bottom up and the top down? I'm going to give a few examples because the data and the pictures are worth 1,000 words, and instead of just theoretically talking about it, I'm going to show how it works. And what you see here on my first slide is the city of Los Angeles, and you see a satellite up in the upper right, you see measurements made from a mountaintop, you see communication towers spread out throughout the city where we have sensors, we have aircraft that we use, and this is just an example of how a place like Los Angeles, using a multi-tiered observing system, can benefit from this kind of powerful information for planning and how to improve sustainable, having a sustainable society going forward. So first thing I want to remind you is why do we have the UN Framework Convention on Climate Change and the Paris Agreement, and in fact the Montreal Protocol as well. All of these efforts of humanity to work together to do a better job with resource management and growth come from measurements. The measurements rang the alarm bell. You see the killing curve of global concentrations of carbon dioxide there on the upper left. You see the temperature record on the bottom right. And so it was these measurements that showed what was happening in the case here of climate change, but also for the Montreal Protocol as well, with the measurements that rang the alarm bell. And then the research community for a long time has been talking with the policymakers and saying, we have these capabilities that we've been improving over the last decades of using the atmosphere to help guide. But in the beginning of time, scientists were a little too grandiose and naive, and were saying, we're going to verify your emissions that you're doing from the accounting point. And that was not a helpful approach to just say we're going to check. It's better to combine all the information, to work in a unified, integrated way. And so, in fact, this is how the progress was made with the treaties, in terms of formulation of the Paris Agreement. There was originally the Kyoto Protocol, and back during COP15 in Copenhagen, this was still a national treaty approach, which wasn't going so well. And instead of this top-down only approach, in the Paris Agreement, the world shifted to an aspirational approach, where we said, what can each country do? The developed and developing countries, what can they bring to the table? with nationally determined contributions. And so that going away from top-down only to this aspirational approach work. And we believe in terms of using measurements, this will also bring the measurements from not only being involved in ringing the alarm bell, but into guiding solutions. And so we want to, again, combine the top-down approach with the bottom-up approach in this way. And so, inspired by that idea, the World Meteorological Organization brought these team of scientists together to create this integrated global greenhouse gas information system, IGIS. We pronounce the acronym IG3IS, we say IGIS. And here's some of the principles that guide us. We want to use this combined approach here in the first bullet. We want to be communicating with the users. What actionable information do they need? We want to use standards similar to the ones that we have for concentration measurements. We have a scale that's been established, and we want to make sure that we're targeting opportunities to guide solutions. That's our success criteria. And we have objectives based on the maturity of the questions that we're trying to help with and the maturity of the science. We've identified objectives, 4 objectives: support for national inventories, support for the global stocktake, support for urban climate action, and support for, across many sectors, those who are trying to find opportunities to reduce methane emissions. And I'm going to give you some examples now for the national inventories and for the methane case. First, we have a science plan for IGIS. We have language that's been negotiated with the subsidiary body for science and technology advice as part of the Framework Convention. It mentions IGIS. The IPCC has the protocol, produces the protocol for how you use bottom-up information to produce inventories from activity data, and they now, in the most recent refinement of those guidelines, have included the use how countries might use atmospheric measurements, and so now they're officially part of that. And also, we've been working with the space agencies of the world, including Israel and NASA and the European Space Agency and others, to look at how we can use, again, satellites in a multi-tiered observing framework for this kind of work. So now I want to do what I promised, is to give some examples of how does this work, this combination of top-down and bottom-up. What does it look like? So in the case of a national inventory, one of the countries who has for the longest time been taking this combined approach where the inventory compiling community has a partnership with the atmospheric scientists, and that's the United Kingdom. And in fact, we have Alistair Manning and Anita Gunnison who participate in that effort online with us. And you can see in the United Kingdom, they've established some tall tower and low tower locations where they have inlets where they pull in the gas from the atmosphere and sensors that then can analyze the concentrations in exquisite accuracy over many different kind of compounds. And if you look here, this one location here on the west coast of Ireland is called Mace Head. It was the first location that the UK had such measurements. And I'm going to show you the other part of the ingredient, remember, is it's not just making the measurements, it's can we from those measurements understand what it's telling us? And so we need to use inverse modeling, backward trajectories. And you can see from Mace Head, sometimes we're measuring just what's happening out over the Atlantic Ocean. Those are the sensitivity footprints Robbie showed earlier in his global map. And now you see later, sometimes Mace Head is actually seeing air masses coming out from over Europe and from the UK. So we use these atmospheric transport model information together with the atmospheric concentrations in an analysis framework to then estimate emissions from the atmospheric measurements and compare them with the bottom-up. And by the way, this quick graph here shows why do we care about HFCs. Robbie mentioned HFCs. This is an illustration of the fact that you see over time this red line shows the increasing global emissions of HFCs, abundance of HFCs, and it shows here above what's happening with CO2 in the projections. And if we're successful in getting on a stabilization of 450 parts per million for CO2, and we do nothing for HFCs, in 2050, that will be added on top. It will be back up in the same level of radiative forcing as we were, as if we had done nothing for CO2 at all. So HFCs are very important, and that's why the Kigali was put in place. But now you see, now here's an example of what did the UK learn when they made measurements and compared to the bottom-up inventory. Well, here's the first attempt in 2013. Maybe not the first, but it's an early attempt. And these bars here show what the inventory, the bottom-up accounting was giving. It was showing about in 2013, about 6 gigograms per year being emitted, and the red line here shows what the inverse model analysis of the atmospheric measurements are showing. It's showing that perhaps, maybe, the inventory was higher than it needed to be. And we really don't know at this point. This is just the beginning. We don't know which one is correct and which one is wrong, but over time, working together with the inventory compilers and the atmospheric scientists, they examined some of the ingredients in the activity data, the refill rate, the penetration rate, and the refill rate is an emission factor. And so looking at that over time, you can see the progress that was made. From 2013 is the blue, 2014 is the inventory reported in green. Yellow here is the inventory that the UK reported in 2016, and now the bars are for 2022. And you can see that by working together, the inventory compilers and the atmospheric scientists are coming closer into agreement, and you can see that the inventory, we believe, is improving as a result. In the US is young at this game, it's just starting. It's not young in terms of having the science. Steve Monska and his team at NOAA have been doing great work for a long time, but we're just beginning to work with our inventory compilers. And here's an example for the very powerful greenhouse gas sulfur hexafluoride. And here you can see that out here, I don't know if you see my cursor, but in the most recent data point here, you can see the red dots are EPA's inventory over time, and these gray and purple and black curve here is what the atmospheric measurement-based analysis shows. And you can see that the atmosphere is still saying that the emissions of SF6 in the US are greater than what EPA inventory is showing. And more than that, I mentioned the power of space and time information, the granularity we get. The atmospheric measurements of SF6 are showing something very surprising, that actually the emissions you see from what the atmosphere is showing are higher in the winter and lower in the rest of the year. And we were very surprised when we saw that at first. We didn't think it could possibly be true because there's no natural sources or sinks for this gas, only manufacturing of it and use of it. But it turns out that we've learned by working with the industry in the US that indeed in the summer months in the south in the winter months is when they take the high voltage transformers, they do the maintenance, which is a big use of SF6 as an insulator in transformers. And now we found through the combination of this work, there's an opportunity for mitigating and reducing emissions of SF6 that was unknown prior to this work. Here's an example, a very interesting one from New Zealand, and this is the first one that I know of that was for atmospheric measurements applied to CO2 itself, not just the non-CO2 greenhouse gases. And here in the 2017 paper of Steinkamp et al., you see these blue bars in this graph are what the New Zealand inventory was reporting for the sink, the land sink of CO2, what the agriculture and what the forests in New Zealand were taking away from the atmosphere, soaking up as a sink. But the brown bars here are much bigger sink coming from the analysis of the atmospheric measurements of CO2 in New Zealand, the inverse analysis. And in fact, That was of 2017, but it's continued to show that these green bars are showing that the inverse analysis of the atmospheric CO2 measurements in New Zealand are showing a much bigger land sink than the inventory compilers and even the models were showing. So this is showing very powerful information for policymakers to have. Now, I'm going to wrap up. I'm almost done. I'm going to wrap up with a few examples on methane. And one of the things to know about methane that we've learned as we looked around the world at the atmospheric measurements is that it turns out that 50%, around half of global anthropogenic methane emissions are coming from diffuse sources that are spread out over space. But there's about another 50% that comes from very few locations, about 5% or less of sites, that are due to super emissions, big leaks, that are coming from oil and gas operations. You see here in blue on the upper part of this red slash, from waste management, from agriculture, from confined animal feeding operations. Often we can get big super emissions, which are, again, a mitigation opportunity. Here's an example in California. A group at the NASA Jet Propulsion Laboratory published a paper in Nature in 2019 that was a survey of the whole state of California's methane inventory. And what they found was that it's even a more extreme case where less than 0.2% of infrastructure was responsible for about 43% of California's methane emissions from point sources, from oil and gas, infrastructure that's leaking, from confined animal feeding operations, etc. And in fact, here's an example from California where we use a multi-tiered observing system approach where the Japanese GOSAT satellite saw this in the upper left-hand corner, a hotspot of methane emissions in the Central Valley of California. And then on the lower left, you say, well, what's going on in that 50 kilometer pixels? What human activity is there? Well, it turns out there's a lot of oil and gas operation and also big dairy operations that have confined animal feeding and anaerobic digesters that sometimes leak. And in fact, when we combined the aircraft mass balance observations flying over these sites, we were able to identify that it was a dairy attack confined animal feeding operation that was the main source of that hot pixel that was seen from space. And in fact, using the imaging spectrometer, they were able to fly over that site and see exactly where the leak was coming from in that big confined animal feeding operation. Here's one last example. This is again the city of Los Angeles, and you can see these red dots that are spread out here are communication towers with sensors that measure very accurately carbon dioxide and methane. And here you can see the inverse model analysis for Los Angeles. And these red and orange spots show what the inverse model analysis of those 12 tower measurements are showing us. And most of those align with places that we expected there to be emissions from landfills and from oil and gas, etc. But this square box that I've highlighted here, there was no known source. It was a neighborhood, and we were very surprised to see these hot pixels there. But when we flew an aircraft with an imaging spectrometer over this neighborhood, you see a golf course here and a big red plume of methane over this residential area. We reported this to the utility company, and they went out with their trucks and found that there was a distribution line that had broken. And so our inverse analysis of this tower network in the city of Los Angeles alerted us to something that was a danger and the source of methane going to the atmosphere. And that same network also showed that the sun
Can you wind it up because your time?
Yes, I can. We see that this is true, and this landfill had the big emissions they fixed the leaks coming from the landfill where methane gas was coming, and in fact, you can see a big reduction in Los Angeles emissions over time. So, to wrap up, we have a big opportunity for translating these research successes to do this combined top-down, bottom-up. I hope you've seen the power of it in some of these examples, and I'm sorry for going on too long, but I hope that it inspired you and gave you some thoughts about how we can see the discussion going forward the rest of the day. Thank you very much.
Thank you, Phil. I think you made an extremely good case for why we should measure, and with an extremely good example. So thank you very much. I will now request Sumana Bhattacharya from Climate Change Ecological Solution, New Delhi, to speak on India's current standing in monitoring and emissions of GHGs and ODs.
Yeah, so it is interesting to note that, India has been a signatory to the UNFCCC since 1992 and the Montreal Protocol since 1987. The Montreal Protocol was phasing out, and in the 1992 onwards we have been estimating the emissions gas by gas, and that's an annual estimate that we are doing. So what wonders the real-time assessment through a satellite can do of plugging the emissions at a point source. So it was very interesting to see that. But I would be presenting what India has done so far in terms of the inventory development by sources. Can we go to the next one? So the policy drivers for GHG inventory and ODS inventory has mainly been the Can we come back there? Has mainly been first the UNFCCC, then the Paris Agreement, and when the Paris Agreement came into being, obviously the entire world wants to have a temperature rise less than 2 degrees centigrade and preferably less than 1.5 degrees centigrade. And in order to do that, the scientists came up with the fact that CO2, methane, nitrous oxide, HFC, PFC, and SF6, which are not controlled by the Montreal Protocol at that point of time, need to be the targets. And therefore, each and every country that is a signatory to the UNFCCC and also the Paris Agreement, they started reporting. So now we have the biennial reportage, which is every 2 years the reporting is done, and all sectors that are mentioned in the IPCC 2006 guidelines covering energy, industrial process and product use, agriculture and other land use and forests, and of course the waste sectors, they are covered. So there are subcategories which run into hundreds. Then internally also that every country has taken up these NDC, that is nationally determined goals, which are 2030 goals. These were published in 2015 first, and then again they have been ramped up. So the latest one says that earlier we were saying that we would be able to reduce the emission intensity of our GDP by 30 to 35% by 2030, but now we are saying that we will be able to do that by 45%. Now the confidence comes from the fact that we have a lot of policies on ground which are towards use of clean energy and maybe also use of renewable energy, which are replacing the conventional energy, and as a result, at this moment, we have around 42% of renewable energy and 58% of fossil fuel in the power sector itself. And we are saying very, strategically that we will be able to reach around 45% of renewable energy by 2030. And I think we'll be able to get over that. Most probably, it might become 50-50 at that point of time. Also, we are looking forward to creating an additional carbon sink. So every time Phil and others, Phil was showing that how the sequestration levels are actually larger in New Zealand than what the estimates are. I was really happy to see that. So maybe through the satellite monitoring and other monitoring sources, we'll be able to enhance our CO2 sequestration in the country, which of course from 1980 onwards has increased in terms of sequestration. Now further, we have taken up goals is 2070 goals, and 2070 goals are that we have to become carbon neutral. Now, in addition to these greenhouse gases that we are talking about, we have to have the HFC control as well. Otherwise, we will not be able to reach that goal that we are talking about. So, for example, of course, we have talked about Montreal Protocol, and the Montreal Protocol, we have gone from to Kigali Amendment, we have gone from CFCs to HCFCs and HFCs control, and of course, India has, is still drawing up its framework, how to go about it, but it has stated through its government publication that it will be able to reduce the HFC emissions by 85% by 2047, and to reach that 85% it will go in 4 steps: 10%, 20%, 50% and 85%, so on and so forth. So these are the drivers which are actually driving the industries, which are driving the agriculture sector, which are driving also the waste sector in reducing their emissions. Now, going to the next slide, I would like to show you that how GHG emissions are increasing over a period of time. This is from 2000 to 2016 onwards, but India actually had reported since 1994. So there is a continuous increase in emissions from the all the sectors and of GHGs. But if you look at the CFC, which of course another person who came before me has shown, just next one, that the ODSs, we have had a very good control. ODSs, we have had a very good control. So we peaked in 1999, and after that, we have been reducing continuously. So India has played an active role in control of ODSs, but due to our developmental paradigms that we have to adhere to in order to reach the SDG goals, still our emissions from the GHG sector are still increasing. Now, coming to the replacements of the ODSs, next. So I'll just give you how much is the percentage of HFC, PFC, and SF6 in the entire GHG mix that we have. It is only 2% of the total, whereas CO2 is 79%, and methane is 14%, N2 is 5%, and the rest of it 2% is coming from here. But this actually does not give us the real picture, because we have not been able to map all the sources of HFC, PFC, and SF6 emissions, which are either in terms of consumption or in terms of fugitive emissions. We have not been able to track that, and nor do we have the exact data for that. Therefore, the percentage might increase to 5% later on, but this is the scenario at this point of time. Next. So, if you look at the numbers, so we were having a conversation yesterday with Yogesh, and he was saying that between BOR2 and BOR3 there is not much of a difference in the non-ODS compounds. So I looked up the National Communication 2 that was published in 2000. I mean, that has a reportage of 2000, and then in 2016. So, for example, HFC 134A was reported in National Communication 2, whereas in BUR3 it is reported to be not occurring. And then HFC 23, CF4, C2F6 and SF6, they are different compounds in these families of HFC and PFC. They are also increasing as per our statistics, but in case of SF6 there is a decrease. Next. But where are the gaps? So if you look at the crosses, these are the sectors where we need to assess the HFCs, PFC, and SF6 movements. So more than 90% of these sectors we have not yet been able to cover. And if we cover these, they can of course be covered at one go through the satellite monitoring and through other monitoring processes that we are talking about. But also to understand the flow in terms of quantity, we need to identify and map these, how much is coming into the country and how much is going out. And maybe CFCs are still existing in the country because of some imports that we are doing, and we do not know what is, either it is CFC or some other chemical that is coming in here. Next. So why they are important? As you can see, the GWP potentials are very, very high. Compared to CO2, we have SF6 at 23,500 and HFC 23 is at 12,400. Therefore, it is important that we quickly find replacements for these chemicals, and so that our curve towards, instead of increasing, it goes down every year. Next. So the gamut of HFC, PFC, you can see that how many chemicals are floating around here, and the GWPs are ranging from less than 1 to more than 23,000. And so we have HFC family, we have the PFC family, we have the fluorinated ethers, we have the hydrocarbon compound and other compounds. All of them are being used in some form or the other in our industrial process and product uses. Next. So we need to bridge the gap because temperatures are increasing. Not only the average temperatures are increasing, but also because we are having more events of extreme heat, and they are likely to increase over a period of time till 2100. And that means that the usage of cooling will be very much in demand. And if that is so, that the little minuscule amount of per capita cooling that we use in our country, that is going to increase many folds. And if we are not able to address that at this point of time, then we will be in a problematic situation. Next. So scope where we can do it, because the industry is here, that's why I included this. That one is the space cooling, where we can reduce the demand by having space cooling, which can be addressed through passive cooling architecture and designs of buildings, and improve efficiency of cooling, shift the demand, adapt all these space cooling in cities. Then cold chain and refrigeration is another area where we need to act. So maybe we should have renewable energy technologies in certain cases. We have to have efficiency improvement and better operation and maintenance. But in all of this, we can do a replacement also of the ozone depleting substances and the HFCs that are being used. And the transport and air conditioning systems also need to be addressed. So HFC 23 is prevalent now. HFC 152A is under development. HFO 1234 has a GWP of 4, so it is available now. R744CO2 has a GWP of 1, is also under development. So these are under development, and how these can be integrated in our industry is the question that we need to address here, because that is how the policy will be panning out in the future. Next. So what we need to do is, of course, based on my previous speakers also, they have pointed out that we need to have a continuous mapping and monitoring of GHGs and ODS replacements by source, continuous monitoring of concentrations across the landmass, which will actually lead to an MRV of what we do from bottom-up activity-based emission estimates. Then enhanced R&D and patenting on alternate cooling and refrigerating agents. Provide appropriate fiscal and policy incentives for speeding uptake of low GWP replacements. Updated affordable housing policies, because passive cooling is one which will be required, especially the labor who is going to work in these extensive heat, where our heat levels are going above 46 degrees centigrade. Even last year it was recorded in March and April. So enact a national policy for district cooling. Guidelines for cities to integrate urban passive cooling measures in planning, align SLN program strategy with the India Cooling Action Plan goals, and include industries in domestic carbon markets, so that the ODS replacements can be can be put in the market as CO2 equivalents and get the carbon credits. So these are some of the things that I thought need to be done, and I should be flagging out. Thank you.
Thank you very much for providing the overview about the emissions in India and also suggesting the path how we can control it. So thank you very much, and thank you very much for keeping the time limit. So thank you. Now may I request Mr. Nilesh Shah Joint Secretary, Ministry of Environment, Forest and Climate Change, to speak on India's needs from policy and management perspective. Mr. Nilesh Shah.
Very, very helpful, and she, under which Phil, who has talked about IGIS, that is the working group for under the World Meteorological Organization. So, without spending much time, I invite Oksana Tarasova to kindly speak on a WMO perspective in this area. Oksana, over to you, please.
Thank you very much for this invitation. It's an honor for me to talk whatever time.
Yes, we can see.
It's okay?
Yes, it's okay. Yes.
Okay, fantastic. So, greenhouse gases and the consequences under Montreal Protocol. And thank you very much for introduction. I work in WMO Secretariat, and I'm working specifically in the area of greenhouse gas coordination. Let me get a little bit back about what do we know about the greenhouse gases and why are we looking at them in general. Well, we know that the surface of the Earth could be significantly cooler if there's not the presence of greenhouse gases. And in order of the fact out of the anthropogenic greenhouse gases, we have carbon dioxide, methane, and nitrous oxide as the most important greenhouse gases. Also, if we look at the diagram in the recent IPCC report, we have seen that the fluorinated gases are also mentioned with a considerable contribution to the increasing temperature is the nitrous oxide. And the key three gases have both the natural and anthropogenic origin, which makes it really interesting and very impactful in shaping the mitigation action which we undertake due to those climate feedbacks. How do we know about the levels of greenhouse gases? The Global Atmosphere Watch Program of the WHO has been working in the area of greenhouse gases as a program since 1989, and actually the first meeting on the carbon dioxide measurement technique already happened under coordination of WMO in 1975. And what we look at is a very precise measurements which are made at the number of stations around the globe, following the same measurement protocol that allow us to understand what is the trend in the global levels of greenhouse gases. And you can see the plots for the global averages of carbon dioxide, methane, and also some hydrocarbons. And on the plot which is related to hydrocarbons, you can see actually the bending of the curve and the concentration in the atmosphere is going down thanks to the Montreal Protocol. So basically looking at the atmospheric concentration of the key greenhouse gases would serve as a key success indicator for any policy measures or any measures related to the mitigation of those gases. And the data related to greenhouse gases are available in the World Data Center for Greenhouse Gases supported by Japan Meteorological Agency. Those data are really powerful in driving international policy, but there are critical gaps that exist in observations. You can see that many ecosystems are not covered by the measurements. And also, the data which we produce, they are very high quality, but they are global in nature. And oftentimes, those data do not allow to support the decision making, which is happening in much more scale. And the information which is required to support the mitigation action, which is happening on the policy relevant scale, is the current status of the emissions as a baseline. Then we need geographical distribution and sectoral distribution of emissions, and not just the annual totals. We need to understand the expected response in atmospheric concentration to the mitigation action, because it's the concentrations in the atmosphere which ultimately drive the change in the radiative forcing in the climate. But we also need to understand the response in those concentrations is a feedback to the climate, because we have a potential climate feedbacks with warming climate, increasing emissions of the key gases in the atmosphere. So basically, what we need is information which we provide on a routine and sustained basis and using the internationally agreed standards. But at the same time, we need to tailor the information to the individual decision-making skill, because providing the global concentration or providing the national total doesn't help all the decision makers to take the decision related to mitigation. So how can we get to the emissions? We can use the bottom-up approach, which is regulated by IPCC following the national guidelines, and those emissions combine the emission factors and activity data. But they have some uncertainty associated with those data. They also provide a national total, they provide an annual basis, and they provide it with a delay of 2 years, which is also not very helpful when you try to make a decision and when you try to see if your actions do have an impact on the concentrations or not. Or you can do the top-down estimates, which is the utilization of atmospheric observation, combining them with ecosystem and ocean observation, and providing the estimates based on atmospheric measurements. The combination of both would be the most extended source of information and most comprehensive source of knowledge to drive emissions, and we encourage to use those. But when you apply those methodologies on the smaller scales, you need to make sure that those methodologies are applied consistently across the different nations, across the different sectors, and across the different scales. And we've already heard the presentation from the Kola about the integrated global greenhouse gas information system, which does serve as a mechanism for those smaller scales to be consistent across the scales, from industry to cities to countries, contributing to the global stocktake, and at the same time tailoring the information to the decision makers, in helping the decision makers in support of atmospheric concentration data to improve emission estimates, find out additional emission reduction opportunity, and also provide a framework for the coherent set of the good practices in the guidelines. And one of the examples of the work of IDIS is a publication of the urban greenhouse gas emission observation and monitoring good practices, which actually provide guidance on the solutions how atmospheric-based methods can be used in the urban setting, providing different solutions for different approaches with the measurement technique and the modeling technique, depending on the question of the stakeholder. At the same time, as we're talking about use of the infrastructure and use of the advanced modeling, the implementation of the IDIS methodology is pretty limited in the number of the countries, in the number of the settings where this methodology is currently implemented. Ideally, what we would like to see is something like what you see on this plot. We want to remove the fluxes of greenhouse gases everywhere with a high resolution and with a time on this, which is not a 2-year delay, but as soon as possible, pretty close to the near real time or the monthly time scale. And we want those products to be robust, continually produced, and not just a one-off exercise of the research community. And that's basically the motivation why WMO started looking at an integrated, internationally coordinated approach to the network design, operation, and the use of observation and support of the greenhouse gas estimate. So we are looking at creating the framework which will allow to produce this greenhouse gas information, very similar to what has been done in the global World Weather Watch. When you have a set of the centers which produce the particular product with an international data exchange, with an integrated observing system, where the network design is done based on the principles and the needs of the system and not just on opportunity basis. And then there is an understanding of what is the product that is produced by the system and common approaches to the quality assurance of the output, collaboration on algorithms, and more components. So keeping this paradigm in mind, we started thinking about what can already be used and what is already in place. For example, there are several countries and international organizations which are investing in the carbon monitoring capabilities, including surface-based, space-based observation, multi-indicator simulation. But at the same time, there is no agreement on the international standards related to the measurements from different platforms, or the number of products, or the international data exchange. There is no integrated approach to network design. There is also no mechanism for sustainable observation, and we see that many research activity, as soon as research funding is finished, they actually stop. And there is no continuation, which actually is not very useful when we want to have the operational product. And also we want to have an agreement on the utilization of the global model products. So the idea is to start feeding those elements. And to understand how we can facilitate the process, we announced a workshop in Geneva in May 2022, looking at making the case for the coordinated greenhouse gas monitoring infrastructure. There were about 100 participants in the workshop. Some were online, some were in person, which come up with a number of the recommendations, looking at the where are already available coordination mechanisms and how we can fill the gaps in the coordination, looking at the expansion of the observing networks, in particular in the regions where those observations are missing, and establishing the cooperation between the modern centers who are working on the production of the inverse models, fluxes, and concentrations. That led to the decision of the Executive Council in June 2022, requesting the constituent bodies of WMO, Infrastructure Commission, Services Commission, and the Research Board to develop the concept for the WMO greenhouse gas related activities and the version for those activities and the concept of the potential architecture of the greenhouse gas monitoring infrastructure. So to initiate the work, the joint study group between those constituent bodies was established, and the group started working.
Oksana, I can just conclude as.
Okay, so the group started working on it. It looks at the landscape analysis, the code capabilities, the input requirement data, and system output. So I will skip the slide. And the range of application which can be produced from this global system is coming from the establishment of the baseline to the quantification of emission from the hotspots and attribution to the specific sector. And this is where IBIS will play the particular role in getting the international agreed methods and standards on the processing of the data. This is my last slide, just to articulate why is it WMO and not any other agency who is trying to do this coordination of the activities. We have a system in place which helps to set up the requirements for the observing system and network design. WMO is an international standard setting body with their regulatory materials which are produced and with the compliance mechanisms in place. We developed the protocol and system for near real-time data exchange and coordinate all the aspects related to the near real-time operation of weather and climate. And the participants of the workshop, they agreed that the internationally coordinated routine greenhouse gas monitoring infrastructure is urgently needed, and there is no obvious alternative to WMO as an organization to coordinate this. Thank you so much.
Thank you very much, Oksana, and thank you very much for providing all the integrated approach. And then we are certainly looking forward for your all cooperation after the end of the workshop. With the recommendations will come, and I think you will also be able to contribute to your excellent effort which you are doing for the international community. Without wasting much time, I just now go to introduce Dr. Amit Garg from Indian Institute of Management, Ahmedabad. He is a focal point, in fact, in the emission inventory from Government of India, and he has done a tremendous work. And if I keep on introducing him, it might take time. So I just directly go to him and present. He was very much wanted to come here, but he is so extremely busy in IPCC and other commitments that he has agreed to do with this. So with this, I call upon Dr. Amit Garg, India's capability in emission inventory development. Over to you, Amitji.
Thank you very much, Dr. Devi, and My greetings to all the past and very learned speakers and all over the world. So it is an honor to be here and presenting in front of you all. So I think I don't have any slides, so I will speak extempore or maybe. So I think if we try to see these inventory estimation, as I think it was indicated by previous speaker from WMO, it is bottom up and top down, both are there. So top down, how the satellite eye sees it or how the modeling has been done, and bottom up is sectoral things as we estimate them. Of course, there are uncertainty at both levels, so we are not saying that this is better, that is better, but of course, we have to debate in some time. But capabilities have been built in bottom-up estimation over, I think, 30 years in India. We have 5 sectors: energy, industrial process, product use, agriculture, land use, land exchange, forestry, and waste. All these sectors, and every sector also has some sub-sectors, like for example, road, under transport, under energy. So this is third level of sub-sector in that. And then there are categories. So for example, energy, then transport, then road. Under road, there are different type of gases, different sub-sectors, categories. So that they combine. If you see, there are 5 sectors, there are 100 categories, 100 sub-sectors in all, and there is up to 150 categories which are estimated. There are 3 things important. One is IPCC generates and has created through a process of human process inventory estimation methodologies. So these are 1996 revised 2006, then many for forestry, and of course 2019 latest for fugitive emissions. So India, and this is IPCC, the second thing is UNFCCC. So where all the decisions are made after discussion across 196 countries, and there, as per UNFCCC reporting requirement, we have to follow 2006 guidelines to the extent possible and capacity is permit. So India, in our latest reporting to UNFCCC, we have taken 2006 guidelines to most of the extent. We have taken 2006 guidelines, barring a couple of resources out of 250. We have taken 2006 guidelines, which is a big, I think, capability enhancement in India. That is number one. Number 2 is if we say emission estimation, there are 3 things to this. First is methodology estimation. Second is activity data estimation and collection. Third is emission factors. So for India, if we see all emission factors, there is more than 200 odd emission factors across transport, road, agriculture, cattle, forestry, so many are there. So out of these, if we go to tier 3, we have to conduct new measurements, new estimation, and as per the latest inventory, which India is preparing for submission very soon, we have taken 70% emission factors or estimation is based on tier 3, higher tier methods. So that is a capability which has taken lot of time, lot of measurements have been taken, lot of estimation on emission factors have been done, and Indianizing the global emission factors. So somewhere we have to use IPCC before, but we try to go to the high tier, especially for key categories. Now, key category is something which is all categories, all of these 200 all categories, what I told, the categories that contribute to 95% of emissions are called key categories. And in India, there are about 25 key categories which are contributing 95%. So those key categories have to be taken to a higher level of estimation. higher level of emission factors, more national emission factors, and more detailed data collection. So this is being done already. Now, on activity data, we are collecting through multiple sources. It is not only through one way, and as which was spoken about, we also collect data from large point sources. We also collect data from area sources. We also collect data from various levels. In fact, the first LPS-based inventory was made in 1996. I think there is a book we wrote on that inventory. LPS, large point source based emission inventory. So anyway, activity data is under constant improvement. Emission factors are under constant improvement, and we have mostly shifted to 2006 methodology. So these three are things. Coming beyond this, the reporting requirements, as I said, are decided by UNFCCC. The review requirements are also decided by UNFCCC. So reporting means how do we create inventory, how do we report. There are table A, table B, or table 1 and 2, and then there are specific guidelines 17 CPA, which are to be followed by every country to report emission estimation. Apart from this, there are review guidelines. So every country's, developed countries and now developing also, are in a way analyzed, and the inventory submission is analyzed, and then there is a team of technical experts for developing country, which consists of 10 experts picked up from all over the world, 5 from developing, 5 from developed country. They review, they analyze the inventory of even developing country, and then there is a separate team which is analyzing and even going to the country and analyzing their annual inventory and reporting. So now I think the important thing has come, a point has come in time where every country has to report their true enhanced transparency framework, ETF. And enhanced transparency framework is for reporting by December 2024. Every developing country party has to report. So that is something which is a very advanced framework which requires all these reporting on a 2-year basis, and also the future projections to be provided for every category, which is, I think, a key challenge which developing countries are facing now, because extrapolating is one way, but creating modeling to do extrapolation, to project the estimate of emissions for, let us say, 2030 is going to be a challenge. And as the previous speaker has said, that we can also have to monitor the progress on policies and measures which every country is doing. There are NDC submission until 2030. So under Article 6 of Paris Agreement, every emission reduction has to be due diligently proved. If you want to sell it outside, of course, if even you want to contribute to NDC reduction, it has to be done very detailed way of under Article 6 of Paris Agreement is to be done. So for that, we may require more and detailed experts, I would say experts to be prepared, to be trained, and I am very glad to inform this House that India has already 7 experts, more 37 are under training by UNFCCC on various sectors, on various things. So we will have a substantial number of experts within 6 months, and they will all be used. I think they are in different sectors. Some are inventory, some are projections, some are RSO, some are different estimation methodologies, financial FTC, financial technical and capacity. So all these experts will enhance in their capabilities to report the next DUR and BTR, not D1, BTR now. Then it has to be linked to NDC through 2 ways. One is every policy, as I said, has to be converted into actions taken. so converted on emission mitigation which has been done. So this is, let us say, India is having 450, approximately 450 policies which are applied at maybe national level, state level, which are directly or indirectly mitigating climate change. Plus, there are policies on adaptation, reducing and making, enhancing the resilience. So all these policies, I would like to assure the House has a market link with it, has a strong maybe measurement basis along with these policies. We ourselves have done until 2030. About 150 policies have been taken through. So this is how much emission mitigation will happen. This is India's capability which we have been working, developing a morning team. So without measures, with existing measures, with additional measures, three lines will be drawn. How future will look like for this, and every mitigation action will be monitored and taken through due diligence process on this. So there are many institutions, about 200 experts from institutions and 24 ministries of Government of India and departments who are working on this thing. Already for last about 25, 30 years we are working on this in different modes and expertise. We are now planning to create a national system, which is national system is for National Inventory Management System, which will take care whatever I have said, which all be documented, legalized, and then taken in. And of course, there will be a place for the top-down estimation in this. Our own teams are doing it, but we have to be very clear that the sector is very complex. The inventory solution is very, very complex, and this requires maybe presently about 98% work is being done by bottom up. We have trained people, we have given frequency guidelines, we have IPCC guidelines. Now, we are developing a top-down estimation, but we have to be very clear, we have to keep a sense of proportion in these things. We cannot throw baby with the bathwater, which has to be seen. I think I will stop here. Thank you very much.
Thank you very much, Professor Dev. We will certainly, whatever you will be enriched with your experience, and we will come back when we will have recommendations and other. Thank you very much for sparing time for such a busy schedule of yours. Thank you. Now I call upon Dr. G.R. Bhatt. He is basically a very senior scientist. In fact, he is a lead from Indian Government, Minister of Environment and Forest and Climate Change. And then he deals as a scientist as well as a policy maker. So basically a combination of this, which is what India and international community needs. So without wasting much time, I request Dr. J.R. Bhatt to please deliver his talk on India's science and policy of greenhouse gases and climate change. Over to you, Dr. Bhatt.
Thank you very much. Am I audible? Yes.
Yes, you are audible.
Okay. Respected Dr. Shailesh Nair, Director of NIAS, Dr. Phil Nicola, Co-Chair WMO IG3IS and University of Maryland, Dr. Gufran Beg, Faculty of NIAS and convener of this strategic roundtable, also the Ashutosh Mukherjee Chair Professor at NIAS, Dr. Shrikant, Head of Energy, Environment and Climate Change Program NIAS, Dr. Tejal Kanikar, Faculty NIAS, Professor Amit Garg, friend, ladies and gentlemen. Good morning and greetings from MOEFCC. Thank you very much for inviting me to this strategic roundtable on the formation of Science and Policy Consortium for GHG and ozone-depleting substances in India, and also giving me an opportunity to speak. speak on a topic which is very close to my heart. And my job has been rendered very easy by the previous speaker, Dr. Amit Garg, who has ably articulated a number of policy points. So I will touch upon only a couple of points which I feel that are important given the topic of this strategic roundtable. First of all, let me begin by saying that India recognizes that global warming is a global collective action problem to be solved through international cooperation based on multilateral agreements, especially the UNFCCC, its Kyoto Protocol, and the Paris Agreement. While discussions and mutual exchanges and climate action may be promoted through other bilateral and multilateral exchanges and through other such agreements, institutions, and initiatives, these should work to promote the objectives, principles, and commitments of the Convention, which is the mother treaty, multilateral treaty, and we as a vast developing country, we repose our faith in multilateralism. So, these other such arrangements should not undermine or dilute or erode the foundational principles of convention. Having said that, let me also emphasize that India considers Article 3.1, 3.2 to be fundamental to the convention and the international regime, especially its basis in equity and the principle of CBDRRC. India also recognizes the fundamental importance of Article 3.2 of the convention, which states that developed countries must take lead in climate action, because this journey of tackling the bull by the horns is not possible for any single country, and developed countries have pledged that they would take lead in tackling the global climate problem. India also works for the implementation of these foundational principles across the board in all aspects of climate change. And the key principle for operationalizing the concept of equity as stated in the Convention and its Paris Agreement is that all countries must have fair and equitable access to the global carbon budget, which is a global commons within which their cumulative emissions must be limited. On this basis, India asserts its right to a fair and equitable share of global carbon budget. At this stage, let me also emphasize one point, that the report card for the world is out, and report card is from the IPCC AR6. The summary for policymakers of the AR6 Working Group 3 report, which has been released just this year, has clearly noted that entire Southern Asia is only about 4% of historical cumulative anthropogenic emissions 1850 to 2019, even though the region includes almost 24% of the global human population. I repeat, only 4% for entire South Asia. Now, to stay within the fair share of the global carbon budget, every country's emissions will have to eventually reach net zero. Similarly, on the path to net zero, emissions will have to peak. But the timing of the net zero and extended timing of peaking for each country should ensure that cumulative emissions stay within their fair share of the global carbon at India, we have now stopped telling what we are doing to tackle this global problem. But let me add here very quickly that apart from resolutely addressing climate change domestically, India has launched the international coalitions such as the International Solar Alliance and the Coalition for Disaster Resilient Infrastructure. And recently at the COP26 in Glasgow, new initiatives under CBRI and ISA, this IRIS and the Green Grid initiative, One Sun, One World, One Grid, were also launched. Along with Sweden, India also co-leads the Leadership Group for Industry Transition, LEAD IT, for low carbon transitions of hard to abate sectors. So what am I saying here? I am saying that India is already making considerable efforts and undertaking climate actions across its entire economy. India has also a long tradition of reverence and respect for nature that provides broad-based societal support for India's proactive climate policies and actions. And I am very happy to inform that India has already achieved its pre-2020 voluntary contributions, and its policies and actions are acknowledged to be compatible with 2-degree warming on the 14th November 2022. Both these documents lay out India's vision and approaches towards reaching net zero by 2070, which are, of course, expected to evolve as necessary over time. By submitting updated NDCs, India has joined a list of some less than 30 countries who have done so, and with the release of its LTLEDs, India has also joined a select list of less than 60 parties that have submitted their LTLEDs. Conscious of the time allotted, let me also very quickly say that we note the voluntary character of the NDCs and that of Paris Agreement and its implementation, and that they are not undermined on the plea of new initiatives and new work programs, and that need for enhanced ambition must be exercised within the terms of Paris Agreement. So much on the policy side, and let me very quickly say that implementation of the enhanced transparency framework, including the GHG inventories and the biennial transparency reports, will be by the parties and is based on party commissions, and that these cannot be overridden by global techniques of monitoring, reporting, and verification, especially through satellite remote sensing methodologies that may tend to bypass or override the party submission processes. So our take on the whole process is that both bottom-up and top-down approaches should be employed, should be gainfully utilized, and one should complement the other in achieving the objectives that are laid down under the Convention and the Paris Agreement. Lastly, the role of the non-CO2 gases, including methane, in global warming and the need for reduction in emissions can only supplement the main duty to reduce CO2 emissions that are the chief drivers of temperature increase. In particular, we in India note that the significant role of methane as a GHG is due to the emissions from the gas and industrial sectors of the developed countries, the contribution of agriculture and livestock from developing countries are predominantly the survival emissions of the small producers who bear the brunt of the impact of climate change. despite having contributed for nothing to the problem. At the end, let me say that India walks the talk on climate change issues and speaks from the position of strength and responsibility on global environment issues, be it climate change, biodiversity loss, land degradation, etc. With these words, I once again convey my greetings to all of you, wish you very productive deliberations, and I also note out of my curiosity a very important point which has been in the brochure, and I am tempted to read this, that the strategic roundtable will explore the what, the how, and the all-important so what for capturing new opportunities in India. Thank you very much for your patient hearing and wish you very productive deliberation.
Thank you very much, Dr. Bhatt. It was very, very useful, and then I'm so happy that when we were having a preliminary discussion, we echo your sentiments, whatever the things which you told, and we will certainly like to take India as a lead with government and whatever the views we expressed. Once again, thank you very much. Now, before closing this particular session, what I feel that before getting into the panel discussion, we can have a question answer session for some time for all the speakers who have spoken from 10 o'clock onwards. So very brief, and then I think Dr. Bhatt may stay for some time, and then if audience has some questions, please quickly you can ask.
Most certainly, sir.
Yes, Phil, you would like to ask?
Thank you, thank you so much, and thanks to all the speakers this morning, and I look forward to the discussion beginning now and for the rest of the day tomorrow. I wanted to react to a couple of points briefly. One, in Sumana's presentation, I was very excited to hear the needs that she laid out on the table, because for those halogenated industrial gases, the atmospheric measurements analyzed with inverse modeling are exquisitely powerful to add to the activity data and emission factor approach, and can provide very powerful information across the full suite of these industrial gases and reveal lots of exciting opportunities. The other thing I wanted to mention is in response to Dr. Bhatt's presentation just now. I'm very grateful to his participation. And in terms of emissions coming from all the sectors, including agriculture, both all types of agricultural activities, I think that one point to be made is that there are many agricultural engineering work being done that intends to capture, for example, methane emissions and turn that into energy, and also from waste management to capture emissions of methane from organic waste and turn that into energy. And what the atmospheric measurements allow is to find the places, like I showed in my presentation, where there's leaks that are unknown and that they're not intentional. And there are super emissions that don't need to be there and are wasting the energy that was intended to be captured. And so it's these kinds of operations that in fact add value to the large and small agricultural activities, and also add value toward climate mitigation. So looking for that kind of low-hanging fruit that's a win-win is just one example of how the measurements allow us to manage the resource management much better, and to achieve the goals that were intended already by the engineering being done and the work being done. So I think there's a lot of opportunity that adds to the livelihoods of people and also mitigates climate.
Dr. Bhatt, can you would you like to make a few comments? Dr. Bhatt, you would like to respond?
Thank you. Thank you for that overall observation. I must add here that agriculture in developing countries, you must appreciate is different from agriculture in the developed countries. In the developing countries, uh, the agriculture is done by small marginal farmers who till hard, toil hard, they produce food for themselves and they also make their nation self-sufficient in terms of food security. There are no evidences of agriculture. And then I also made a point which needs to be appreciated, and that is the entire Southern Asia, India included, which India itself is home to 1/6 of humanity, and we are the second largest rice exporter. We have the largest cattle population. But our total emissions from 1850 to 2019 is less than 4%. And of this 4%, if you take this 4% as 100, yardstick of 100 of the fifth, our agriculture emissions are 14% of this 4%. And of this 14%, methane is minuscule. Very little. So, the point that I was trying to make is that developed countries have not been able to reduce their emissions domestically. Now they are finding ways and means of passing on this burden to other countries that look, we will give you money, we can take carbon credits and so on, and we will try to do all this. But to make agriculture as a site of mitigation for these poor people to be told that now you also mitigate the climate problem that we have caused and which is harming your entire existence, your survival emissions, is not a very fair approach to dealing with this problem of climate change. Developed countries, if they have to demonstrate to the world that they are serious, they will take lead, they will provide finance, technology, capacity building, they will take the bull by the horns, and they should reduce the emissions domestically rather than finding extraterritorially and wanting small and critical farmers to mitigate climate change for them and for the world. That is our take as a nation on this. But that doesn't mean that we are not aligned to the new developments in the subject, including methane, or new innovations which lead to reduction of greenhouse gases and so on. So this is our general response to your observation. Over to you, Dr.
Yes, thank you very much, Dr. Bhatt, for clarifying and giving an elaborate answer. Just another Dr. Rajendra Shinde, just briefly please, sir.
Yeah, I know the time is very short, and the answer to my question probably will take quite some time, so I'm not very sure whether I should raise it. But Dr. Bhatt made an excellent point about share of India in cumulative and historical emissions. I have a great sympathy for that because I myself is an Indian, so I'm very proud that we have not contributed to the problem and now we have been asked to find the solutions for that. And this is a part of the climate justice which Prime Minister keeps on talking. But we have been talking about it for a long, and the climate change problem persists. So, knowing that we all are scientists, technologists here, policymakers, a question to Dr. Bhatt will be, I think he talked about allocation of carbon budget. Have you prepared a proposition to put forward to the global community that, okay, this is a carbon budget and each country should take up that? I mean, this is not something dreamy or visionary idea. We did that in the case of COVID-19. I mean, in order to do vaccine equality, I mean, at least WHO tried to do that. We don't know whether we are successful. But can now India being G20 presidency can propose carbon budget and each country follows that?
Okay, thank you very much. I think Dr. Bhatt, you just wanted to respond.
Okay, sir. I will be very brief. First of all, my respectful regards to Dr. Rajendra Shinde, who has spent his lifetime on ozone-depleting substances and the science behind all that. So, any question from his side is expected to be a difficult one. And I must say that you see, in terms of urban budget and all that, within NIAS you have a lot of distinguished professors here. Dr. Tejal is here, then Dr. Shrikant is there, Dr. Day, and so on. So there are a number of new publications, highly peer-reviewed publications, which are there allocating carbon budget to different countries. So it is not an abstract metric anymore. It is the way to operationalize the equity. And this is what the IPCC 3 working groups have ably demonstrated. Working group 1 has talked about carbon budget, but group 2 has talked about, and working group 3 has also in detail deliberated on this. And in terms of countries' fair share, you can also see it on the Climate Equity Monitor, which is hosted jointly by MSSRF and NIAS, very proudly. So Climate Equity Monitor is another source. And thank you for asking what you asked. And by merely, your presence, you are taking me down the memory lane for past 3 decades when we started working on all these issues. So thank you, Dr. Rajendra Shinde. And please also have solidarity with us, not just your sympathies. We need the solidarity for your sympathies. Thank you very much.
Thank you very much, Dr. Bhatt. It was really very insightful, and your presence has made really very exciting. I think now, because of the paucity of the time, maybe other things we can discuss in a next session. We are already running by about 5-10 minutes. I immediately hand over the session floor for the panel discussion, which will be steered by Professor A.R. Ravi Shankar from Colorado State University. So over to you, Ravi.
Thank you very much. Can you hear me okay? Especially on the ones online, I assume. Being the moderator, I'll take the prerogative to say a couple of quick things, if I may. First, the speakers have talked about what needs to be done, how it should be done, why it should be done, etc. From different perspectives. So the perspective of people making policy, people implementing policy, and people actually providing information. So it's time for us to dive a little deeper into these issues. The second thing I'd like to very briefly mention is that the work, from my perspective, what I think we're talking about is not just what is needed to fulfill the obligation to the international treaties that India rightfully and proudly is a part of, but it is actually also to enable policy making and management within India. And that brings a very important point, and that is, who are the stakeholders for this? It is not just the policymakers, It's actually where does the rubber meet the road, so to speak. The various sectors and people involved in it. And I would argue that local knowledge is absolutely essential to do this right. I'll just tell you this is a very short story. I grew up in a village in South India for the first 10 years of my life. And when I was at a meeting on methane emissions, people were using methane emissions from the field, which is a small pot that is flooded, and multiplying by the total area of the agricultural fields. Having grown rice, my father was a farmer, I said, do you realize what you're doing? That's not actually where the methane comes from. It's simply when it's flooded. So that changed the emissions by a factor, I don't know, a large number. I'm just trying to point that out. Not that that's something that it's just a local knowledge of how things are done in India is critical for doing this. Third point I just would like to mention is research is important, and it's also very important to remember no paper is the final thing. Science progresses, we learn, we adapt. The adaptive management is essential, and so in this process, let's not hang our hat only on the research papers. Let's kind of think about operationalizing and providing, as Professor Naik said, actionable information that can be continuously modified and improved. The fourth quick point is, I think science is important, and it's important because it's essentially the people have to have a trust in the science and the technology. We have seen this in many, many cases. The COVID is a classic example. Lack of trust in science and medicine can have disastrous consequences. Okay, and on the other hand, having trust, having the right build-up of trust rightfully is essential. Having lived in America for 50 years, I can tell you, this lack of trust in science can be a really major problem for society. So with these thoughts, I just thought we can dig deeper into this. And the reason I brought all this up is the question we are trying to answer is what needs to be tweaked to strengthen India's science framework in this area and the intellectual merits of a consortium for doing this kind of work. So we know why we are doing it. We know what the payoff is. Now that we've heard all this, what is it that we would like to do slightly differently? And so with that, I'm going to start with the panelists for quick comments, and then maybe people could interact with questions. I realize that we have essentially 1 hour, roughly. So we have about 6 speakers. So shall we go in the order I have here, if I may? The first, call upon Dr. Jagmohan Sharma from MP.
Thank you, Professor Ravi. You have laid certain boundary conditions, and I would certainly like to respect all of that. Though when I looked at the title, in itself, it was such a title that it presumed that there is some structure available, and we need to consider that structure and then suggest as what could we be doing in capacity of individual institutions and overall framework. But in any case, let me introduce myself as a person from the government, and the question of trust that you raised, which is essentially of having ownership of any research outcome or any data that is collected. So that is where we come with, and we have recently started a very aspirational project to talk about the SLCPs, particularly and it has the context of overall pollution levels that we see, and particularly in the city we live, Bangalore, we're finding that the situation, the livability is gradually going down, and there is a need to do something. And the second thing that I would like to emphasize is that we understand that data is available bottom up and down. However, still the granularity of it is missing, and for action to occur, there is definitely a need to identify what is happening where, as has been adequately emphasized by the speakers who have spoken before me. And let me also mention that we are very enthused with the presence of your own presence, Professor Ravi, and hearing you, Professor Garg and Phil and Oksana and Sumana, and my succeeding speakers, from where I will be taking note very intently as to what we could be doing, how we could be going ahead. So as we prepare to undertake that exercise, which is grounded, that is, we essentially wish to build a baseline of SLCPs, which are 4 in number, about which we need to, as we develop the inventory design, some of the designs are available, but we find there's a limited capacity with us to review them for their appropriateness for us to undertake this work. So I find there's a lot of support coming from, say, Professor Garg, who mentions about the overall country level program that is on the experts. Those are likely to become available in due course, and certainly I would reach him out for assistance in terms of the review of such inventory design, because that's a key challenge, and we would, I think, through this exercise be able to, one, augment the data that is available. We could contextualize the data for a situation that exists on ground in Karnataka today, which is an important province of this country, and which lays the foundation for, say, suppose we collaborating with other people and gradually expanding the area for collection of such data. And secondly, whatever data is available, I trust it would become available to us, so that some kind of a verification, if I may say so, could also happen at the same time when the data gradually now becomes more robust. So I'm very excited to undertake this work in Karnataka. We have assistance and collaborations from at least 2 institutions by now in this regard, and I definitely think that we'll be able to do a baseline for SLCPs, which would, I would think, be a work in progress, and as the methodologies Professor Garg mentioned are available, 1996 greenhouse gas inventory methodologies and 2006 methodologies, we need to see as to, in this context, beyond GHGs and beyond the major sectors, land-based and energy and others, what else we might require. So overall, we are very happy to be part of this conference. That is one. I trust, and I certainly believe that this is the most timely organized event, particularly for us, because we are getting into that exercise of undertaking this ground level work in this state. So thank you very much for the opportunity, and Mr. Phil and others who have provided us very important inputs on connecting this kind of a work to the larger situation is most welcome, and it adds to our imagination and also our responsibility to be working very responsibly and creating a database that is reliable. So thank you very much, and thanks for your kind attention.
Thank you for your comments. If I heard you right, 2 key points emerged from what you said. One is the inventory design, second is the availability. Am I right? Great, thank you. Sorry.
I have to. All right. I
I have learned quite a lot. I come from a different sector. I work largely yeah. And so some of the things that I think perhaps would be useful to discuss further and put on the table in terms of this entire complementarity as well as tension that we have seen between the bottom-up and the top-down approaches. There need not, of course, be a tension. There definitely is complementarity, and I think that is fairly well demonstrated by various presentations since morning. The tension, however, happens because capacities to undertake top-down assessments are differentiated across countries, and I think Dr. Bhatt spoke at length about this. That who monitors and who has the sovereign jurisdiction to monitor some of these, especially sector-level emissions. And if there is no trust, and we spoke about trust in science, if there is no trust in the process, then this tension is likely to only continue to remain. And so that's why I think that the process, linking it to the entire IPCC and the UNFCCC process is important, because that is where some of the trust building really happens. And perhaps we can begin by looking at the large sources. I think Professor Dr. Nicola's presentation spoke about methane leakages and the way in which you can detect some of these early on, so that we can, in fact, avert even tragedies, not just necessarily build on inventories, and they can have many implications. There have been recent studies that sort of contrast the EPA methodology of estimating methane flaring and leakage versus actual airborne sensor-based estimations. I am not really, it's a Stanford study, I'm not really aware of how robust the estimates are and how well they correlate with ground-level bottom-up measurements. But the EPA methodology basically plugs the number of leakages at about 1.4%, whereas this this is in the, I think, it seems to be a problem with the mic. Okay. Thank you. It says that the leakage can be in fact more than 9%. Of course, this is not uniform across different infrastructure, depends on the age of the infrastructure as well. But if, where capacities are high, for example, in developed countries, especially in the context of oil and gas exploration and extraction, if this can be demonstrated how top-down methods can in fact improve estimates of leakages and especially of SLCPs, then perhaps there can definitely be much more trust and confidence that developing countries would develop in also adopting some of these methods to looking at our own inventories and emissions estimates as well. I would also perhaps pose the question, and maybe the experts in the room can answer this in terms of how we would deal with, given the large amounts of exploration of LNG and LNG terminal setup, etc., that are happening. How is it that methane accounting would take place for transport-related emissions from some of these sectors? Right? Is it possible to have top-down estimation for these potentially very high-emitting sectors going forward into the future, especially in the near future? And so perhaps that can be one method, where if this is where we begin the focus on methane from, the trust in it can be built, and developing countries such as India as well as others can then build capacities to also undertake this. In terms of agriculture, since the subject was breached, of course, Dr. Bhatt spoke about how we have small and marginal farmers. Of course, detecting things at that level of granularity becomes very difficult. But to treat and knowledge from the ground then becomes very important. But because you have such a disconnect, if you begin the process by treating farmers, especially small and marginal farmers, as data points, we are going to get nowhere. So we perhaps begin, and the government, the IMD, the IITM have excellent programs already in place to provide agrometeorological bulletins. We've done some studies about the same at NIAS, about how these can build adaptive capacities, increase productivity, etc. In some regions where we've done the study, we found significant impacts for rain-fed crops. So through these processes, if a relationship can be built with with cultivators, with the agricultural community, by providing improved resilience and adaptive capacity, then perhaps that relationship can be taken forward to build more interactive. We can get feedback in terms of data, in terms of data on flooding, for example, in paddy cultivation, or other kinds of water use and optimal input use management. But if we start with that as a starting point, especially in the context of Indian farmers who are already severely overburdened, we may not get very far. So I just wanted to put that on the table. And maybe end very briefly with a question of how we deal with CO2 in this entire, the framing is in terms of GHGs. The focus seems to be SLCPs, which is understandable, but if we frame the entire question in terms of GHGs, the biggest one is CO2, and how robust are our methods of looking at top-down assessments of CO2, whether we have capacities only to look at fluxes, and even with those, how is it that we separate historical stocks in our estimations from short-term fluxes in CO2. It's a well-mixed long-lived gas, so what kind of capacities do we need to build then in that particular sector as well? So I'll stop here. Thank you very much.
Thank you very much. So again, just to make sure I heard you right, I'd like to make sure I got your main points. One, trust issue, right? The methodology, you actually implemented an excellent starting point for certain kinds of actions. With that, did I miss anything? CO2. Okay, thank you. Okay. Next we have, this is excellent. Upendra Tripathi. I'm really looking forward to your comments. Every time I talk to you, I find something, I learn something new. So over to you, Mr. Tripathi. We can barely hear you. No.
Can you increase your volume?
Volume is too low. Still louder. Yeah.
It's better for a second, but went back down.
Yes.
Okay, I switched over to my mobile. Yes. Started to get better. Yes. Well, I did, thanks to NIAS for the invite, and I am an adjunct professor there, and I really enjoy my study. I remember when, in the initial stage of internet science formation, Mr. Algo had come in here, and he talked about the inconvenient work. And the response to that group, and then Mr. Murthy had written something for convenient action. And
ozone management, that itself will be a great thing, because one is a successful story of the entire world. There's a bunch of protocols, anti-guide amendment, the achievements we have made, and Dr. Singh is here, one of the scholars in that area, and Dr. Bhatt, who gave a speech. And so this forum, if they can take the lessons from ODS, the ozone management story, and put it into greenhouse gas emission, that itself will be a big success. To give you one example, I was studying in Harvard University doing research into India's ozone management policy. Now, we had a booklet by UNDP about the cost-benefit analysis of ozone management in India. And that talked about very specific things. Again, you identify the problems, the technological problems, identify who are the people at the grassroots who know the problem, who are actually struggling for a solution, and you can guide them. Now, if today I would like to put my hands on a book like cost benefit analysis of global warming on any particular country, I don't think UNDP has such a publication. The point is, we need such things, and maybe somebody has written about cost benefit analysis, but this particular forum, while bringing together policy and science, because one without the other is actually meaningless. Pure science without a policy support, or pure policy without scientific support, they won't reach very far, and they won't be change agents. So to sum it up, this is a combination of GHG and what actually impressed me in the combining with ODS. So a success story and a story of struggle. This itself will be a lesson. If we can take the best 10 lessons from India's ozone management or world's ozone management and bring them to the greenhouse gas emissions. And number two, when you talk about greenhouse emissions, first you usually get a graph. Energy is 73% responsible. Within that, transport, industry, we talk about agriculture, we talk about livelihood, we talk about waste management. Now, each of these sectors, if we want to reach net zero, whether by 2050 or 60 or 70, we need to have a sectoral approach. I remember my professor at Carlton teaching policy sciences, talking about a vast decade. And to see life, it is not a single thing. You can have pieces of this cake and distribute it too. And that really applies to this global house, gas emissions that we talk about. It comes from agriculture, comes from a waste, comes from benefit a lot more from this sector and industrial sector. And if actually brings the people who matter in each sector and identify the problems that was the mission and the technologies which are available and transferable and the finance they need. That will be a field level contribution to the grassroots. The second question, what are the merits of this forum? Now, as I told that there are 4 points. I feel this will be needed. As some top speakers told that this forum recognizes that we need more action than discussion, and of course discussion itself provides a room for action. But something we have to find out how the discussions, the writings, the activities of the forum could be more action oriented. It will lead to real action, measurable, and of course, which will help in reducing the global greenhouse gases. And number 2, we find that within India, there are R&D organizations, there are several organizations in the civil society sector also, with a speed, skill, and scale are not the same. For example, NIAS, where I advise globally, they have got a program in Gujarat. It's called Green Village, and right at the grassroots level, they do a carbon assessment of the village, and they find solutions, and which can be given speed, which can give the skills to the people who need it, and it can take to different level of skills. So at some point, if you talk a net zero or a net zero world, we need action at the level where it matters. I mean, the level of individuals, level of grassroots levels, and then of course the number 3 merit that the consortium help to have in its objective is perform, reform, and transform. Overnight, we cannot reach net zero. But that point, every organization involved has to perform, and then find out areas of reform, and then find out areas of transformation. And this is what Prime Minister Modi told in his launching the business of alliance, that the entire world has to perform, reform, and transform if we would like to reach a net zero world. And the best point in this consortium, it has brought today the actors, ideas, and institutions together. And this is very critical. Whether India would like to be net zero by 2070, or China by 2060, or most other countries by 2050, we have to bring the actors, the ideas, and institutions together. And of course, the motive of bringing this together is to facilitate solutions by way of identifying the technologies we need and the finance that should come from. At some point, the International Solar Alliance talked about a World Solar Bank, headquartered in India. That was based on a different model of risk coverage. How do you actually provide risk finance, which attracts 10 times more capital from the private sector? So to sum up, the idea of the Science and Policy Consortium for GLG and ODS is a brilliant idea. And inherent in it the success story of ODS and ozone management. And we have to draw lessons, at least 5 lessons from the ozone management history of the world. And then we implement to the GLG sector, that global greenhouse gas emission sector. And I think wholeheartedly support this brilliant idea of NIAS to create this forum in India, which will bring actors, ideas, and institutions together from all over the globe. Thank you.
Thank you very much. Clearly, I think what I heard from you is the issue of policy, science, interdependence, and using the success story of the Montreal Protocol to what you call the struggling story of greenhouse gases. I must say you have a way of communicating ideas. It goes right there with your pieces of cake you told me. The other thing is the grassroots missions and facilitating kind of a bottom-up way to manage things and actually make things happen. Am I right?
Yes, absolutely.
Great, thank you so much. With that, I'll to the next speaker is KV Josh from NEERI.
Yes.
Dr. Chu, although you are, I'm sorry, I met you before, so.
I know, sir. Thank you, Dr. Ravi Shankar. First of all, good afternoon to all the members, the gathering of climate moderators, I call, and that's the objective of this group. I thank Dr. Shailesh Naik and Dr. Gopral Beg of NIAS for inviting me so that I can hear what are the views, your views, and let me share my views on this subject. I'm not from the climate change background. My background is air pollution control. Now, it appears that the two are same. No, there is a gap.
And this is the point where I want to say why I am not a climate change person, not in that group. So let me put my points. We are discussing since morning mainly on the research and development aspect of production of new gases, the industry-oriented aspects of greenhouse gases, our commitments. So if I classify it, for ozone depleting substance, first we produce or find some substitute having lesser potential. Then at the end of its life, it is released. Then we measure and create emission inventory. Now this point, release of ozone depleting substance, this is where we need to be, where we can do some action besides finding substitutes of lower potential. On greenhouse gas emission front, we are trying to reduce consumption, energy consumption, and increasing the use of green products. Now, let me take the liberty of driving you to the left side of the economic spectrum. All these activities that we are discussing is oriented at the right side of the economic spectrum. What is expected or what should shift towards the left side of the economic spectrum? I refrain to call them poor because they are also happy people, so poor is not the appropriate word. On the left side of the spectrum, what we have is a big market of consumers of green products, energy consumers. But I realize one more market is available, and that is the market of habit change. There is a big population. If they change their habits, there will be a reduced energy consumption. And that can be one of the objectives in this direction. So in the inaugural address, Dr. Shailesh Naik mentioned 3 points: to generate knowledge on emission, and then social system and human system, where we are interacting on these 2 things. Can we think of infiltrating the knowledge generated to the left side or to the section which are actually the driving force, users? So one way is energy literacy, which people are doing. One of the courses which I learned is from the Swaraj Foundation, Energy Swaraj, led by Professor Chetan Solanki, the solar man of Rajasthan. Climate literacy, is it going in an official way or in a structured way to the other side, or the left side of the spectrum, through education in the schools or in their routine functioning? One example I can say, those who are dealing with the air conditioning system, when I call them sometimes that the system is not working, their mechanic comes and says, gas is reduced now, I need to recharge. I don't find any mechanism that the gas which is in a compressor can ever leak. If it leaks, the pressure is so high that everything should leak. So can we say that by your action of doing such a silly thing, we are releasing harmful gases into the atmosphere? So this literacy is needed on the left side. Now, when we think of a major step, we talk of energy conservation to reduce greenhouse gases. We talk of buildings which are green buildings, which are energy efficient buildings. But if we talk of a baby step, not the bubble step, because bubble steps are unsustainable only for small scale industrial sector to sell some of their product for short duration. Let us talk of the baby steps. A few years ago, we were asked not to take the printout from the ATM machines to save paper. But today, and gradually we are shifting to digital economy. We need not carry our boarding pass or railway tickets. But still our normal paper size is A4 size paper. So when I come to a hotel, he asks for my identity card and uses one full paper just to print out a very small size photo ID. Can we change this habit? This is one point. Now, when we introduce these kind of baby steps for changing our habits, we should not be stressful towards the lower income group. One of the examples which I have seen is in the African continent, Zulu tribe is facing the issue of tuberculosis. WHO interfered, then realized that in India also there are some tribes which are facing tuberculosis. The reason their houses have only one door, no window, no second door. Why they prefer it for winter season? They want to retain the heat inside. Now, in that process, they make their cook stove inside their house. Whatever heat is generated, they retain it. Now, when we enter into we means from urban centers, the urban technology enters to save them, we may sell them cook stoves of catalytic wash coat or something. These technologies will not survive there in the rural sector. So, how we should help them in overcoming their health issues without disturbing their traditions or compromising with their needs. This is one of the issues. Now, besides sensitizing the left side of the spectrum, on the right side itself, there are communities. Is there any way wherein judiciary or media is sensitized about the climate change issues? I am reading climate change issues because it is of my interest, personal interest, not professional. Similarly, other communities may not professionally need it. How we can make them realize the importance of these things, it's a must. Now, just now Dr. J.R. Bhatt mentioned about India's emission from 1950 to 2019, it's 4%. Now, if we change our habits, in future also, we will continue to lead in lower energy consumption. So therefore, our objective should be to bring all people from all spectrum into reduced energy consumption or awareness about climate change at least. Already we have spoiled our habit by using plastics. Now we are through different mechanisms we are trying to control it. On this issue also, hopefully in future we will reach a stage where we can reduce our per capita energy consumption, which will be helpful in climate change matters. My ideas may or may not be fitting to the right hand ideas of this gathering, but still I had these ideas, so I put it forward. Thank you very much.
Thank you, Dr. George. I think I can summarize what I think I heard. Change the focus to the user.
Yes, sir.
Is the way to go. And you came up with lots of examples of how to reduce emissions. Thanks very much. The next on the list is Suruchi Badwal from Terry. Oh, you're here.
Yeah.
I was looking at Terry. Thank you.
Thank you very much for the opportunity. I would just like to present a few areas of work that we at TERI are involved in with regard to GHG inventorization and working on ODS phase out. We at TERI have a program on climate and air, and it's an independent research institute think tank based out of New Delhi, which has a backing of more than 3 decades of work in the climate science mitigation and adaptation space. I do echo the views of the panel earlier in the day with regard to the use of both bottom-up and top-down approaches for GHG monitoring. We have ourselves been involved in the bottom-up approaches with regard to looking at different sectors and sectoral emissions with regard to various scales at the national level and at the subnational scales. But we're also in discussion with other organizations now globally with regard to use of top-down approaches, the role of artificial intelligence and satellite imageries with with regard to bottom-up approaches that are being used in the country, I think it's very need-based. It is not mandatory for reporting of GHG emissions from subnational scales, but basis which the work that we're doing with different clients and the requirement and the interest expressed by different states, what basically we are doing within the country is also developing subnational scale inventories with regard to emissions from various sectors. Besides this, we are also basically building capacities at the subnational scales in terms of understanding how these inventories are developed and basically trying to make people at the subnational scales independent with regard to the reporting processes, with regard to GHG inventories development and reporting processes. While doing all this work, of course, what we realize is data requirement is critical and activity data has to be made available and at scales and details that they are required for reporting purposes. Also, the issue of emission factors and the need to have it contextualized and developed and used basically considering the local context within the country. We are also working with different corporates in terms of their emissions reporting processes. We're working with different methods of scope 1, scope 2 and scope 3 right now, and in discussions with several corporates with regard to their future reporting processes, which are now mandatory under the BRSR guidelines. We're also working on SLCPs, where we are identifying and embedding mitigation opportunities for SLCPs in the country, targeting certain sources from where SLCPs are being reported, and one of the key areas that possibly we're working in is with the brick kilns, where our approximation is about 15% of the SLCP emissions are coming from that particular sector. With regard to monitoring, reporting, verification frameworks, I think these are hardly existing in the country. And when we talk about things like the global stock take and global compliance with regard to NDCs and other net zero targets that India has, I think this is an area clearly where work needs to be done to link all these, this compilation process with regard to a framework by way of which reporting can be done effectively internationally and nationally speaking. We're also working on ozone-depleting substances. We house the CIF Secretariat on Cooling Technologies, where basically we have been closely following on the Kigali Amendment, and we've contributed to India's Cooling Action Plan, facilitating its implementation, and right now in the process of developing and promoting markets for energy efficient technologies. Also working in the area of the enhanced transparency framework with the UN, and involved in the initiative for climate action and transparency reporting with regard to mitigation and adaptation for India, where we are helping along with the UN basically develop frameworks for monitoring, reporting, verification processes for mitigation and adaptation outcomes. The role of stakeholders and stakeholder engagement partnerships basically are critical in the whole process of our work that we carry out, and therefore we do feel right from the role of policymakers, I think the role of other stakeholders, including those who are involved in the data collation processes, to those who are involved in the implementation processes, to civil society organizations in the capacity building process. I think all of these stakeholders hold value and importance in the whole implementation process that we're talking about. Not to leave aside the fact that with regard to many of these technologies that we're talking about on the implementation side, I think we're also exploring the role of public procurement with regard to green procurement, and this would include considering technologies which may promote the phasing out of ODS, and capacity building components for technicians, service technicians under the HPMP stage 2. We are also helping India develop the strategy for its HPMP stage 3. So these are different things that we are basically doing with regard to the different areas that are being discussed here today. And definitely we do look forward to seeing how we can actively contribute in the process of further partnerships and collaborations that are developing around this topic. Thank you.
Thank you so much. It's clear that Cherry is doing an awful lot of very comprehensive work That would be very helpful. I just wanted to put on the science hat and just say one word of caution, and that is, emission factors are not, it's not a single number. It's a spectrum of emission factors, and how to deal with the spectrum of emission factors is something that we need to kind of consider. Just a word of caution. Thank you. The next on my list was Ashish Jindal from NRDC. Okay, thank you.
Thank you so much. Thanks to NIAS, WMO, IGIS, INSERB, and it's wonderful to be part of this important discussion today, which is personally enlightening to me. I would like to touch upon key actionable items to strengthen and lead India's science framework in the area of GHG and ODS relating to cooling, considering thermal comfort for all is necessity, and based on NRDC experience in policy advocacy and implementation in India. Natural Resources Defense Council is a US-based non-profit advocacy group founded in 1970. As it has been highlighted few times since morning, we have seen a very good news coming in the last few months with India ratification of Kigali Amendment, Net Zero by 2070, and LIFE announcement, which is Lifestyle for Environments, is now leading us into yet another important phase of transition and technology improvements. NRDC and partners just completed an analysis, and our preliminary results suggest that as per India's agreed timelines under the Kigali Amendment, beginning the overall transition away from high GWP HFC, around mid-2020 will result in large installed stock of HFC-based units, requiring stronger and more aggressive transition efforts in the later part of the transition timeline for India. Such a scenario may result for the manufacturer sector to do a transition much faster in the past, for example, what they have done in the past. But the challenges related to cost and safety standards of alternative low GWP refrigerant would be the key. So broadly, I would like to list down 5 key takeaways, which basically NRDC is also supporting to ministries and various stakeholders in India, and which can be very instrumental while we are talking about this area. Is first is improved installation and service practices, plus refrigerant reclamation at the end of life that can play a significant role in reducing HFC demand. So why? Because ICAP basically talks about, for example, by 23 to train around 1 lakh servicing sector technicians, right? But however, we need a systematic formalization and validation of technicians, and their knowledge is critical. And universal certification system is key. We have seen a lot of opportunities while cross-learning between countries. For example, Environmental Protection Agency, EPA, oversees certification implementation. And we have seen their approved companies conduct the examination, passing the examination, and you can say provide an identification in terms of to service technicians. We basically help with a unique identification number and other benefits. Recently, we have seen US has also approved AIM, which is an AIM Act, the American Innovation and Manufacturing Act, that was signed into last few months ago, and it was impressive list that includes audits reporting QR codes on HFC tanks and cylinders, and broadly around, you can say, bringing out refrigerant service requirements in the rule. So these are the important learnings as India gets onto the path to develop its national strategy on HFC next year can be used. Second point is around reducing any refrigerant demand through improved cooling technologies by building the business case. For example, we talked about working with DISCOMs. We have seen ESL bulk procurement, which is a very successful case for the LED program. We can do work around EGEN, right? And how those, you can say, alternative refrigerant can meet the challenges of safety and the price. We have seen 2 important areas we see in terms of data. Be it ceiling fan and room air conditioner constitute major chunk of space cooling, and you can say future demand. And considering the requirement and the stock, I think if we work around it, and there is already a work which is going very, you can say, aggressively around, you can say, standard setting, and around HFC alternative. So this can actually strengthen the market, and you can say GWP and refrigerants. Further, you can say scaling up other programs which NRDC is doing, for example, implementing building codes is. Sorry, there was a noise. So basically, next big thing is how those specific strategies and building related intervention can happen. So we have energy conservation building code that is already, you can see, been notified in major states. Now the adoption and implementation would be the key around this. Similarly, the cool roof guidelines and other technologies can be brought around this. Last, not least, is IoT is yet another opportunity that can bring upscaling and formalization in the sector. So cloud-enabled HVAC tools, smart diagnostic can create a large pull factor for talent and basically incorporating strong training and elements in formal. So broadly, I would like to also touch upon the financing, energy efficiency financing, which recently you've seen the World Bank cooling facility to the GCF has done, right? So there can be multiple other avenues which can be helpful for the manufacturers and other stakeholders which can be work around it. So driving the focus in conversation on servicing and international dialogue is something what would have to be explored deeply. And I would like to end it here. Thanks for the opportunity.
Thank you very much. Appreciate it. Thank you for pointing out a very key thing that we didn't stress earlier, and that is avoided emissions versus reducing current emissions. That's a very important thing to keep in mind. Thank you. So moving on to the next person on the list is Indumurthy.
I'm here.
Hi, there you are. Thank you.
Yeah, very good afternoon to everyone. And picking from the topic that's being given, what needs to be tweaked to strengthen India's science framework, I would think the starting point should be to look at, like Amit Garg was saying, there's an established inventory process in place in the country. And very clearly in the process, what is also documented are the challenges that exist with respect to doing such an inventory at the scale that we are doing. So, which includes obviously, data gaps that even Sumana highlighted. Data accessibility is another thing that it talks about. Capacity and lack of a common methodology when you try to pull in the data across the various sectors. So I would think, picking from where that leaves would be the inroad to coming up with a slightly more robust framework as part of this consortia. And also what would be also important is to value the importance of communication itself. Because a lot of science is generated, is done, but then when it comes to communication, there is a gap out there. So I think as part of the framework that this consortia is trying to build on, looking at communication as an important component of whatever work is being done becomes very, very important. The other thing I would like to pick here, and which somebody else alluded also, is to not try to look at all the sectors, but then pick the big tickets as they call. No, why not? So again, this could emerge from the existing inventory process itself. There are data gaps that are identified, there are data challenges that are identified out there, which could be the starting point for actually doing the proposed work that's being discussed from morning, which would help to reduce the uncertainty which is currently high in some of these sectors. So basically a melting of pots is what is required, rather than looking at this or that. How do we integrate the two? How do we make the inventory process much more robust through adopting one more methodology which is being talked about? Also, as it's been highlighted by Phil this morning, it has its own set of utility as well. A panel that I can think of is at CSTEP, which is a policy think tank. We do work on air pollution. We do emissions inventory, source apportionment studies, which is a bottom-up approach. But at the same time, the team has also been doing or very recently published work which is based on satellite measurements of PM 2.5. Now, what we found is that there are varied utilities of doing these exercises, or even kind of validating some of the work that we do. So I think we will need to look at these two pieces of work that we are discussing from morning as being complementary rather than being opposed to each other, which is where I think would be very, very important. The other thing that's been talked about is, the kind of technologies that need to be kicked in. We do have a low carbon development pathway. India has already announced it, and we have the net zero 2070. There are a whole lot of technologies that are being discussed in this race to net zero. Now, I think here is where, a techno-economic analysis of the technologies, one is technology and economy, but the other is from an emission perspective. And more importantly, I think the circularity of what we are talking about should be at the heart of whatever we are proposing. So I think if these are kept in the mind whenever we are looking at a framework, when we are trying to propose any new ways of trying to improve science, I guess that would add a lot of value to the existing body of work and also pave a path to doing things in a very different manner, which leaves us in an improved space at the end of the day. Thank you.
Thank you very much. It was very helpful. You clearly indicated kind of a comprehensive system that how it could be tweaked. You directly addressed this. Thank you for doing that. I have written down your list. Next, actually the last one for this is Professor Arvind, who is the chair of IPC right here at the Indian Institute of Science. Over to you, Arvind. Thank you, Professor Jayashankar. I'd like to thank Professor Nishun Beg for meeting myself here. Just to introduce myself, my name is Arvind, currently the chair of the Department of Inorganic and Physical Chemistry at the Indian Institute of Science. We have not been working on atmospheric chemistry, but as a physical chemist, I realized the importance of atmospheric chemistry. So I returned to India towards the end of 1994, and in 1995, through atmospheric chemistry won the Nobel Prize. So even though I was not working on it, I encouraged my student, the first student, Rajkumar, to read about it and learn, and he eventually went and did a postdoc with Professor Ravishankar in Nova. They set up a laboratory in Madras. From all the talks, it's very clear that, as the title of field says, you can't manage what you don't measure. Because I was very pleased to see the talk by Professor Griffin Beck, where he showed the methane emission all over India. We need to do it for all the molecules. And as a chemist, I only came to listen here. The contact details are available here. I will be happy to interact with anyone and help in any way we could. One thing I would like to say in response to a few comments, including by Dr. Beck, India can be proud that we have only 4% contribution to the net emission, but is that enough? In the atmospheric chemistry and the inorganic chemistry, as versus them and here versus there doesn't always work. In fact, I was somewhat surprised to listen to Ravi's talk when he pointed out that the ozone depletion could have happened in tropical area. And it happened in Antarctic mainly because of the ice clouds. The gas phase chemistry is not enough. I was hoping in tropical that will never be a problem, but I soon realized I was not asking. The mixing happens over a period of time. So it's only a matter of time. Even though we don't emit as much carbon now, the air pollution in Delhi is a very serious problem. Josh mentioned about it. I have two daughters, both of them living in Delhi, so I have some personal stake in this. So it's not that our farmers, I'm very pleased to hear the
It's not mass production, but production by masses. But still, we need to find ways to solve this problem, because the air pollution in Delhi is a here and now problem, and we cannot blame the West for it. So it's important to make measurements everywhere, all over, of all these vital molecules, and we have capacity. And from the Indian Staff Science, as many of you know, we have a DHR Center for Climate Change. They've been working on climate modeling, but unfortunately, I can't blame anyone else. We do very little atmospheric chemistry. I have been trying to increase this, and I'm glad in IIT Madras they are starting a program, a master's program in environmental science. We will also try to do that, but it's important to have capacity all over India. We need to make measurements, and unfortunately, analytical chemistry was a neglected area in India. It is not fashionable. In fact, now how many of you are aware of Professor Balram, who was the director of Indian Staff Science? In one of the editorials he wrote, specifically talking about the carbon dioxide. And like what he pointed out, carbon dioxide concentration is being accurately measured day in and day out. It's a terribly boring job. But if it was not done, we would not be here discussing. The whole meeting would not have been convened. And if you look at the chlorofluorocarbon story, it's all very simple chemistry, chemical kinetic spectroscopy. Chlorofluorocarbon was changed to hydrochlorofluorocarbon because the atmospheric lifetime reduces when you add this hydrogen. It still had chlorine, so we removed it and went to fluorocarbons. With the global warming potential effects, now we have perfluoroalkenes, which reacts in the lifetime history. These are all simple chemistry, and I really cannot blame anyone else but the chemist from India. I think I can tell you that we'll be happy to collaborate, interact with you, and I'll stop here and thank you for this opportunity.
Thank you, Professor Anand. Bringing us back to the centrality of chemistry, which is very close to my heart. I'm a chemist by training. Thank you all for all the comments. But I just would like to, did I forget somebody? Oh, I thought somebody scratched out that name. Is Sunit, no, he's coming in the afternoon, I believe. Okay, thank you. So, what I think I can summarize what I heard is all of you are enthusiastic stakeholders in development of a greenhouse gas and ODS emission information system. That's what I heard. I hope that all of you are going to actually sign on to this and provide the kind of information and ask of it the information you need to make the work you're doing possible and to improve India's standing in how to do it, how to interpret it, how to use it. So the key message I got from all of you are all enthusiastic supporters of this whole idea of having a formation of a science and policy consortium for greenhouse gases and ODSs. Did I hear you right? Can you all say yes loudly?
Yes, and may I add, Ravi, we can make this the Bangalore Protocol then for India.
Francis, you'll be in charge of that. Thank you. I think we actually achieved, Phil, over to you.
Wonderful job as a moderator there. And one point you made that I think is also a theme has to do with, it's not just engaging with the users of the information. It's entrainment, to use an atmospheric sciences term. We look together to make sure that what we're designing together and improving the information from the combination of top-down and bottom-up really helping people sleep better at night and make better decisions. And the only way to achieve that is with the users of the information, the policymakers and decision makers, seen intimately as part of this consortium. So I just wanted to emphasize that really important point that you brought out from the panel.
If you think it's over to go from,
Yeah.
I'm done.